Who Noah says is Pennywise's brother. It's his nice brother, though.
Can't be the nice brother of a
Pieces.
Pieces. Okay, so listen, piecewise is exactly what it sounds like. It is a function that's graphed in pieces. Okay. How do we determine what the pieces are going to look like? We determine it by domain restrictions. Okay. So it's going to be the pieces themselves are going to be super duper easy. All right. The restrictions are where it's going to get you.
Is this 2.5?
Yes. If we have time, we'll do the step function and absolute value. If not, we'll save it for tomorrow because I definitely don't want to rush it. Piecewise can be tough for students, so I may just stick with piecewise today. Hopefully you've seen piecewise in Algebra 1 at some point. And you might, whenever I show you what it looks like, you might change what you say. There could have been some on there.
They were continuous on like one side. They're not on like the other. Remember?
This is what a piecewise looks like. Yes, these show up all the time. These are a favorite of standardized tests for sure, piecewise. All right, so what this is saying, these are two different lines, do we agree? But they're restricting them. They're cutting them off. So they're saying this is the equation of the line, but only when x is smaller than -1. If x is bigger than -1 or equal to -1, this is what the equation is going to look like. Okay? These are easy because they're in what form? Slope, intercept form. Okay? And when we graph and slope intercept, we go to the intercept and then apply the slope. So go to -2 and go up 1 over 1, right? Do y'all remember that? Linear functions? I certainly hope so. Yes? Okay. All right, so what I'm going to do, and this is not the way that you will do it every time, but just to show you what piecewise is, let me show you what happens here. If I have this graph, this just, I think, helps you understand it a little bit better. I got this graph, and I'm going to graph x minus 2. That means it's got a y-intercept of -2. The slope is 1, which means what? Because it's mx plus b is the form -2. And so I go up 1 over 1. Do we all agree with that? You really only need 2 points, but I'll give you an, oh, my hand hit this. I'll give you another. All right, so does everyone agree that the first line graph without any domain restrictions looks this way? We all okay on that? The second line then, what's the y-intercept? 3. And the slope of this one, same thing, right? Up 1 over 1. Right, how do you know they're parallel? They have the same slope. That's exactly right. So now let's look at that. Let's look at the domain restriction, okay? So for the first one, the one that's in yellow, it says if x is less than -1. So this is the point that x is -1. Do we agree? That's my cutoff. So if x is less than -1, which way does x get -1? Get less than -1? To the left, right? So my graph for that yellow one is not going to include any of this. Come on, eraser. Don't be like that today. You're going to be like that today. Like, why do you have to think about erasing? This is ridiculous. There we go.
Are you running on your computer?
Yeah. I just didn't hardwire in today. I Bluetoothed in. That might be why it's slowing down a little bit. All right, here we go. So from this point, this way, but Look carefully at that domain restriction. It's less than. So can it be negative 1? No. So what I have to do is I have to come to where it's negative 1. This is not working. But I'm going to do an open dot there at negative 1. Okay? Just like on a number line when it's exclusive and I do a little open dot, I'm going to do the same thing here. So I'm going to put an open dot to let me know that it does not include that point, but it does go on forever this way. Okay? So that's that piece of the function. Now, the white one says if x is greater than or equal to negative 1. So again, here's my negative 1, right? So which way does it go? Up, but to the right, right? My x's go to the right. I'm to the right there. So I'm going to erase up to there. Okay? Does it include it or not?
Yes.
Yes. Okay, so I'm going to do an inclusive dot. Okay, now understand, is it a function now? I hear no. Why? Okay, you say vertical line test. There's only one point that they have in common. What's that point? Negative 1. Does it cross the graph twice? But does it? It does not, because it doesn't include this. So the point of piecewise is we're forcing them to be functions. These two lines, when they were graphed, were not functions. They'd fail the vertical line test, right? But we restricted the domain, and we restricted it in such a way that every vertical line is going to pass. So it is a function now. Okay? F of x telling me that it is a function. Yes?
So it's like, in every one, is one going to be like, without, like, one going to be explicit, so that it's not.
For the most, well, sometimes. It just depends. You could have some that, remember that one we did from homework where the whole middle part, there wasn't a middle part? It's still a function. Yeah.
But I thought since like the dot was open, it doesn't like intersect.
It does not. That's why we said it passes the vertical line test.
Oh.
Because it only intersects one, really. It's what it's doing. Yes, Connor? Yes, you can. All right, let's do another one. Let's pick it up just a little bit. Now, I'm going to say to you, when you work these, it's a little messy if you start going in and erasing lines, right? Do you see that we could plug in the domain, the endpoint, get a point, and then go in the direction we need to go in? Does that make sense to you? Do you see what I'm saying? Some of you do. If x is less than negative 1, then I could plug negative 1 into my equation, right? And I would get the point negative 1, negative 3. Negative 1, negative 3. I would know it's an open dot. And because it says x is less than negative 1, I need to find a point to the left. So I'd do open dot and I'd go off to the left. Let's do one like that so we're a little more advanced than erasing. All right, look. If x has got to be, how many points do you need for a line? Okay. If x has got to be less than negative 1, one of my points I'll plug in negative 1. That'll give me my open dot down here, right? My second point, I'm going to choose a number less than negative 1, so maybe negative 2. I'm going to plug that in, get negative 4, and then I can connect and go from there. Same thing if I look at the second equation. I'll plug in negative 1 and get what?
What do you plug it in for?
X for x. And get 2, right? If I plug negative 1.
So when you plug it in, it's always going to be y.
Yes, always. Because this is saying that these are two different equations. F of x equals this, and f of x equals that.
So you take the restriction
And plug it in.
So the restriction is x and you plug it in.
Let me do one like that with you. Let's say that f of x equals. Let's stay easy and then I'll do one a little harder. X, if x is less than or equal to 3, and negative 1 if x is greater than 3. So 3 is my cutoff, right? I'm going one direction with 1 at 3 and another in the other. All right, so think about these individually first. And before I even graph them, what's the line f of x equal x look like? It's a diagonal line, right? Goes through the origin, up 1 over 1. Okay? What does the line f of x equals negative 1 look like? Right? Horizontal at negative 1. So let's think about this. If 3 is my cutoff, what is this one when x is 3? 3, right? The point 3, 3. 1, 2, 3. 1, 2, 3. Is it? I plugged in this for the x in my equation here. Take the restriction and plug it into the function. Is it open or closed? Closed. Why? It equals 2, right. It's less than or equal to 3. So now let's think about this. If it's less than or equal to 3, is that to the left or to the right? To the left. So what's a good x that I could pick that's to the left of 3? I hear 1, negative 3. I'm going to stick with 1. I think that's a good one. What is y when x is 1? 1. It's the equation y equals x. Are y'all following me? I feel like you're not. Okay. All right. I just picked a point, but made sure the point that I picked was less than 3 because I need 2 points to graph a line. Okay. If you graphed this entire line, right, which is what we did the first time when y'all said you understood, the y-intercept is 0, up 1 over 1, right? So this whole line looks like this, right? But then I'd have to go in, use my eraser, and cut off what didn't apply. Instead of doing that, I'm only going to graph what applies. So if you start with the restriction and plug it in, okay? Because that's my cutoff point. So if I get my cutoff point first, then I can find the rest. So plug it in. That's how I got 3, 3. Then I just picked 1. You could have picked 2. You could have picked 0. Why could I not have picked 4? That's not less than 3. That's greater than 3. And it says x has to be less than or equal to 3. So pick an x that's less than or equal to 3. This is why I don't like using this. So we're back now. All right, so what I'm going to do is I'm going to connect these so that it's always less than or equal to 3. Okay. My domain on that first piece is less than or equal to 3. Does that make sense? Yes. Well, you got to have another point to connect it to because then you wouldn't know if it was like this or like this or like this. All of those are less than or equal to 3. So you'd have to know which direction to go. All right, my second piece, just wait till we get into these with quadratics and whatnot. That's going to be fun. Right now we're just starting out with lines. Okay, so now I'm looking at this equation. Okay, and somebody's already said, is that just a horizontal line? That is absolutely just a horizontal line. Okay, so the horizontal line, y equals negative 1, but it's only when x is bigger than 3. Here's so 3, negative 1. If I plug this in, I mean, if you plug in 3 for x, you still get negative 1. Anything you plug in for x, you're getting negative 1 because y is always negative 1. So I need to be bigger than 3. So maybe 4, negative 1. Right? This is the horizontal line. Why what? Because the restriction says bigger than 3.
Why would it go down? It would go up.
This is the line y equals negative 1, which is this. The only difference is I've restricted it. I've said, yes, you're the line y equals negative 1, but you can only be that when x is bigger than 3. Well, you do. If you have y equals negative 1, if you plug in 3 for x, what do you get for y? That's where I got these points. Another.
So, and that's x.
Yeah.
You're just replacing that x in there with x is less
Yes.
than.
Absolutely. All right, look at this one, because then we're going to actually write the equation. That's okay.
So about the 3 lines?
This is going to have 3 pieces. That's exactly right. 3 pieces. Okay? So let's look at the very first one. The very first one says, why is it not there? 2x plus 3 when x is less than 1. Okay? So plug in 1 for x, and what do you get? Does everybody see where that point is coming from? That's the end point of the restriction. Go ahead, Dayton.
The x. One's always going to be on x. Like whatever's on the right side.
Yes, that's always going to be what you plug in first for x.
Okay.
All right, 1, 5. Is it open or closed?
It's open.
Why?
Less than.
There's no or equal to. Okay. Now it's saying x has got to be smaller than 1. So what should I use for another point? 0. Because 0 is smaller than 1. Are y'all following me now? If I plug in 0, what do I get?
0, 3.
0, 3. You got. I'm using 0 in this equation, so 2 times 0 plus 3, which would be 3. You absolutely could. For this one, you could. If you want to use the slope backwards from there, you can. The next one has 2 endpoints. So if I plug both of those in, I can just connect the endpoints. So look at the first endpoint. What happens when you plug, let me do this one in another color. When you plug 1 into this equation? 1, 1. 1, is it open or closed? I hear both. Which one is it? Closed. It's closed. Both of these are going to be closed. Now, if you only need 2 points for a line and I have 2 endpoints, then I can just use those 2 points, okay? So what do you get when you plug in 2? 2, 0, right?
So that one gives you your 2 points.
All right. So it's just between these 2 numbers. So this is just a little piece of a line here. Inclusive because of the line under it.
And because it doesn't go past 1.
It's telling me x has got to stay between 1 and 2.
Where do you get 2, 0 from?
I plugged this 2 into this equation.
Where did you apply from?
On the first equation, I plugged 1 into this equation. The restriction right beside it is the one that goes with that equation. And then for the last one, it's a horizontal line, but x has got to be bigger than 2, right? So it's a horizontal line at 3, so it's going straight across here, but it's got to be bigger than 2. Open at 2, and it goes off forever in that direction. Oh, at 3. I think 1, 2, there you go. It's at 3. The line is 3. 2 is the x restriction. Mm-hmm.
Could you just see that x would be 2 and y would be 3 and then the bottom point at 2 and 3 and then just go play for the next 6?
Yes.
And then just go from there.
Mm-hmm. Absolutely. That's what I would do. I'm trying to take it slow for everybody to understand. The first point of which one? Of the last equation or the very first equation? The very first equation, I plugged in 1 and I got 5. That's this point.
Could you just,
Do the slope from there? Oh, that's actually my open point, sorry.
Could you just look at the lesson or lesson for regular time, and that determines where you want. And then so if you like 2, 3,
that's-
then you see the right 2, you get the right.
Well, but you have to have another point to connect it to. Because think about, you need 2 points to draw a line, right? If you only had this open circle, you wouldn't know if it went like this,
Good morning,
this,
Canton High School.
or
It's time
this.
for the morning announcement. Please stand for the Pledge of Allegiance.